Okay, let's get started with 1-26. And just a couple of reminders. You should be listening to the video. If you are just watching me do this or copying someone else's hard paper copy of their homework, maybe you'll get something out of it, but you would get a lot more out of it if you listen to the video. Also, another reminder, show all work, including diagrams. Many of you notice that I do take off points if you don't draw a diagram. There's reasons behind everything that we're doing, so I may not fully explain the reasoning in the video, but you need to trust that I know what's going to be in the test, not just this test, but future tests, future chapters. And if I'm doing something on homework, or if I'm choosing a particular problem for homework, there's a reason for it. Okay, so let's start with part A. We have a proportion. This is a proportion. When you have two ratios that are set equal to each other, those create a proportion, and we're going to solve. There's several ways to solve this, but most people know that the cross products in a proportion are equal. If you had something like 2/3, which is the same as 4/6, if I were to have one fraction reduced to lowest terms, if I were to multiply the cross products, they would be equal. So you're using that fact to solve for x. So that would give us 11 times 3x minus 1 equals, now here the negative in front, sometimes that throws people off. They think, oh, the 5 is negative. Actually, this entire fraction is negative. Now, to solve this proportion, I am going to put the negative with the 5. I'm going to associate those together. But you could have the negative down here. You could have it just right here in the middle in front of everything. For now, I'm going to just do 4 times -5, which is -20. I just don't want you to think that when you see a negative in front of a fraction that only the top, the numerator, is negative. It's actually the entire fraction that's negative. Okay, we have distributive property here, so that's going to be 33x minus 11 equals -20. Let's isolate x by adding 11 to both sides, and that would be -9, and then we're just going to divide by 33 on both sides. So then x equals negative. I'm going to reduce this to lowest terms. Both of these are divisible by 3, so that would be 3/11. Are there other ways to do this? Yes. I try to pick the way that seems the easiest, but feel free to do this in your own way. As long as you show your work and you get the same answer, you're going to get full credit. For part B, we've got distributive property, and we've got x's on both sides of the equation. So let's go ahead and distribute first. Here's another issue that people have when they see a minus. Remember that that minus is actually adding a negative. So you don't have to write this on your paper, but if it helps you, you can think of this as plus -5. Or if you know that that's a -5 and you just want to remember that, that's fine. But don't get thrown off with that minus. So I'm distributing -5 over 2x minus 3. Bring the 6 down. That doesn't change. -5 times +2 is -10x. -5 times, here's another minus. This is really plus -3. So this is really -5 times -3. So that's +15. Some of you need that, some of you don't. I just want to make sure if you don't understand something from last year that we help you get where you need to be. We have x's on both sides of the equal sign. So there's more than one step you could take here. I'm going to go with what I think is the easiest. When I see x's on both sides, I get rid of the smaller value. So I look at this. This is actually -10x, and this is +4x. So this is smaller. So I'm going to get rid of it by adding 10x to both sides. These are going to cancel out. That's going to give me 14x plus 7 on the right side. Let's go ahead and combine like terms. That's going to give me 21 on the left side. Just checking to make sure I'm doing everything right. And that's going to give me, let's get x by itself. So I'm going to subtract 7 from each side. And if you are still struggling with solving equations, I do have other strategies that I really don't use in the videos. Undo charts is a great strategy that helps often. It really does solve the problem. So please come see me. I can do a special video on them if a lot of people need them. But if it's just a few people and you need that one-on-one help, come see me and let's help you get up to speed with solving equations. 21 minus 7 is 14. Let's get x by itself. Divide both sides by 14, so x equals 1. Part C, we have a fraction, and I wrote it the same way that they wrote it in the book. They put the 3x on top. That's the same as writing 3/4 x. Now, a lot of students, when they see a fraction, think, oh, I don't know how to do that. You could keep this as a fraction and solve this with a fraction. You wind up having to do a little bit more work with fractions, or you could get rid of the fraction altogether. So I'm going to get rid of it, because that's what most people like to do, by multiplying by 4. If I multiply by 4 on the left side, what that's going to do is 4 times 3x over 4, these 4's would cancel. If I was multiplying 4 over 1 times 3x over 4, that would give me 12x over 4, which would give me 3x. If I multiply, okay, and then 4 times 2 is 8. If I multiply by 4 on the left, I have to multiply by 4 on the right. So that's going to give me 16x minus, I'm distributing this 4, minus 4. So that is what we would get if we multiply both sides by 4. We've got x's on both sides. 3x is smaller than 16x. Let's get rid of the smaller one. So 8 equals 13x minus 4. Let's add 4 to both sides. Remember, you always undo addition and subtraction before you undo multiplication and division. If you were thinking that you were going to divide by 13 here, that is incorrect. You would have to undo the subtraction first. When you're undoing a problem, you go in the opposite order from the order of operations. Okay, and then we're going to divide both sides by 13, and that's going to give me x equals 12 over 13. If I'm going too fast on any of this, certainly pause the video when you need to. I do like to write the problems kind of ahead of time just to save space with the video, but do what you need to do so that your work is complete. Okay, for 127, the directions say to sketch an example of each triangle if possible. So some of these are not possible. If it's not possible, explain why not. Refer to the glossary if you need help with the vocabulary. So I have on Google Classroom posted the Polygon Graphic Organizer. So you have this on Google. I want to print this out. It has all the definitions that we wrote out. The ones we wrote, I did not make sure they were completely perfect, but I tried to make sure you had the key elements. The goal here is that you're familiar with these, not that necessarily that you have every detail memorized. Okay, so the right isosceles triangle is on your Polygon Graphic Organizer, I think. Here it is. Isosceles right triangle has a 90-degree angle, 2 sides equal length. These 2 angles here would be equal, and it does have reflectional symmetry. So this is the main part that you need to know. Triangle with 90-degree angle, 2 sides equal length. So let's just sketch that really quickly. Okay, Right obtuse triangle. Well, you can look for this on your Polygon graphic organizer, but if you think about it, can you draw a triangle that has a right angle and then also has an obtuse angle, an angle that's greater than 90 degrees? That's impossible. So you could use this sketch just to demonstrate why it's impossible. This is not going to be a triangle if you have a 90-degree angle and an obtuse angle. Scalene equilateral triangle. Do you remember what scalene meant? That's one that most people don't get in middle school. Scalene means all sides are different lengths. Equilateral, hopefully you remember, means that all the sides are equal. So you can't have a triangle where all the sides are different and then where all the sides are the same. So this is impossible. Acute scalene triangle, I believe that is on our graphic organizer. Oh, it's not acute, we just have scalene. Okay, so scalene triangle, no sides equal length. We just need to make this so that all the angles are smaller than 90 degrees. So it's kind of hard to do without making it look isosceles, so let's do this. That shows that we know what scalene means. It shows that we know that all the sides are different lengths, and then the markings here show that even though these two kind of look like they're equal, the markings are showing we know these are supposed to be different lengths. Alrighty. So you've got this on Google Classroom to refer to. Maybe just save it to your drive. Okay, 1-28. There's a reason you have been doing diamond problems. I think you had some last year. I can't quite remember if Math 1 has this. But there's a reason that you are going to see these over and over again. Copy these and use the pattern you discovered earlier, shown at right, to complete each problem. Some of these may be challenging. So I'm going to draw this one with you, and we're going to add this information to the diamond. Get some of my stuff out of the way. Okay, I know these are a little bit challenging to draw, so I'm just showing you what I do. I do 2 parallel lines, and then I turn my paper a little bit and do 2 more parallel lines. Then I cut one side in half, and then I cut the other 2 sides in half. Doesn't have to be perfect. You'll get better. Please don't draw it so tiny that I can barely read what's in it. Okay, so if this is X and this is Y, remember that the product, and I would like you to write this in on your paper, the product is X times Y is on top, the sum XY is on the bottom. So that relates to what we're talking about this week in terms of area of a rectangle written as a product and a sum. So this is kind of being broken down. You're starting to preview some things that by the time we actually get to the concept, you will know how to do it. So for part A, the product of 6 and -11 is -66. The sum of 6 and -11 is -5. Now you're probably going to have to pause the video to draw your area diamond shapes. So go ahead and pause it if you need to, and just leave blank spaces like I've done here. And there's 4 parts. So go ahead and pause the video if you need to right now, and then come back to it. The product of -1 and -4 is 4. The sum of -1 and 4 is -5. So here we have the product. We know -2 times something is -6. Well, that's got to be +3. And then we're going to add 3 and -2. So that would be 1. Okay, part D, we've got The product is -8. The sum is -7. So what could we multiply to get -8? And when we add it, we get -7. So that's got to be, it can't be 4 and 2, because if you did 4 and 2, that's not going to add up to 7. So it's got to be 8 and 1. Now we just need to figure out where the negative goes. Well, one of these is negative because when you multiply them, you get -8. When you add them, you get -7. So that means the 8 is going to be negative. All right. For 136, we have, if you're following along in the ebook, I forgot to say this in the beginning, but if you're following along, these next two problems are from 122, lesson 122. And I encourage you to have that ebook tab open and be looking at the problem and not just watching me do the video, because it's important to, I'll show you the problem, and in some cases you're almost writing everything you need, but in some cases there's just too much for me to write on the paper. So it's important to be looking at the ebook. If the perimeter of the rectangle at right is 112 centimeters, which equation below represents this fact? Once you have selected the appropriate equation, solve for x. So our perimeter is 112. Perimeter is the sum of the lengths of all the sides of any shape. So in this case, it's a rectangle. That means that these two sides are going to be the same, and these two sides are going to be the same. So that means that 2x minus 7 plus 2x minus 7 plus 4x plus 3 plus 4x plus 3 is going to add up to 112. So let's figure out which one of these represents what we just said. Well, it's not 2x minus 7 plus 4x plus 3 equals 112. That's saying that these two together add up to 112, but it's all four of these that add up to 112. And it's not 4 times 2x minus 7 equals 112, because that's like saying all of these sides are 2x minus 7, but only two of them are 2x minus 7. This is saying if we multiply 2x minus 7 times 4x plus 3, we get 112. But perimeter is not found by multiplying. Perimeter is found by adding. So that leaves part C. This is saying if you double 2x minus 7 and add it to twice 4x plus 3, you get 112. That's exactly what we just said in the beginning. So let's solve for x. So I'm going to distribute. That's going to give me 4x minus 14 plus 8x plus 6 equals 112. We've got like terms, 4x and 8x, that's going to give me 12x. Negative 14, positive 6, that's going to give me -8. Now let's isolate x by undoing the subtraction first. Then I'm going to divide both sides by 12. So x equals 10. All right, 137, write an expression for the area of each rectangle. So I do want these two rectangles drawn on your paper. If you were finding the area of this rectangle, you would multiply the length times the width, or you can think of that as the base times the height. Oops. So my base is 3, my height is 11, 3 times 11 is 33 centimeters squared. Area is in square units, so we want squared centimeters. Here we've got 3x times 11, so that wouldn't be 33, it would be 33x, quantity 33x square, or sorry, whoops, quantity 33x centimeters squared. All right, 138 gives us this equation. And then it says, without graphing, where is the x-intercept? Now, I am going to require that you write down some notes for this problem. This is tied into something we are doing later in the year. And if you understand it with linear equations, you're going to understand it with quadratics. So you've got some notes. Pause the video. Take these notes. Get these on your homework paper. The x-intercept is where the graph crosses the x-axis. So if I were to think about this, you should be able to recognize that this is your y-intercept. So it's crossing the y-axis at a negative value. And then this is your slope. This is in slope-intercept form. So you should recognize your y-intercept and your slope pretty much right away. Y equals mx plus b form has your y-intercept and your slope. So, and the slope is 1/2. 1 is perfect 45-degree angle. 1/2 means it's not quite as steep as that. It's going to be a little less steep. So if I'm thinking about this, I know that that x-intercept is going to be over here on the positive side of the x-axis. So all points on the x-axis are in the form x0. There's something 0. So this is 1, 0, 2, 0, 3, 0, 4, 0, and so on. So that means I know when it crosses the x-axis that the y-coordinate, this is my y-coordinate, the y-coordinate is going to be 0. So I'm going to substitute 0 in the place of y in my original equation and solve for x. Do you need to know this? You should know it at this point. If you don't, if any of that was confusing, please come see me or let me know, and let's come up with some strategies to bring you up to speed. Really just maybe re-watching what I just talked about. If I lost you on any of that, rewind, and maybe you kind of got it, but you're like, rewind, listen to it one more time. This is incredibly important for what we are doing, both now and down the line. Okay, so we're going to substitute 0 for y. That's going to give me 0 equals 1/2 x minus 4, and then I'm just going to solve for x. So add 4 to both sides. Now there's a fraction here. You could get rid of that fraction if you wanted to. I think this one's easy enough that we can handle it without getting rid of the fraction, but you could do what I did on that previous problem and multiply this side by 2 and multiply this side by 2. That would give you 0 equals x minus 4 if you did that. Here we have 1/2 x equals 4. I'm going to divide by 1/2. Dividing by 1/2 is the same as multiplying by 2 over 1. So that's going to give me x equals 8. So my x-intercept is 8, 0. So going back to this sketch that I did in the beginning of the problem, this graph is hitting the x-axis at 8, 0. So I'm kind of visualizing this before I put it on graph paper to think about how I'm going to fit it on the graph paper if you're using a sticky especially. Okay, part B says on graph paper, make a table and graph y equals 1/2 x minus 4. So let's do a table. I'm going to help you out here. You may be thinking, how do I know what values to put in this table? So when I'm thinking about this, I'm thinking, okay, it's crossing at 8, 0, so I definitely want this value in my table. And I'd like to know what it does, maybe starting, about here, and then maybe every other point leading up to 8, and maybe a little bit past 8. So if you weren't sure how to create the table, I would never, I would give you some help on that part. So I'm going to start with -2 and do every other point. And that should give me a nice graph. So let's start with x equals -2. If I plug in -2 into y equals 1/2 x minus 4, okay, if I were using function notation, I would do this. F of -2 is 1/2 times -2 minus 4. The 2's would cancel out and this one would be negative. So that would give me -1 minus 4, which would be -5. Can you do this on a calculator? Yeah, that's fine. If I did the next, if I skip every other point, I'm at f of 0. So f of 0 would be 1/2 times 0 minus 4. 0 is always kind of nice because anything times 0 is 0. So I get 0 minus 4, which is -4. If I plug in 2, f of 2 is 1/2 times 2 minus 4. So those 2's cancel out, and 1 minus 4 equals -3. Let's do 4, 6, 8, and 10. So f of 4 would be 1/2 times 4 minus 4. So 1/2 of 4 is 2. 2 minus 4 is -2. If I do f of 6, let's see, I'm kind of running out of room here. Oh, I'll do this. Okay, f of 6 would be 1/2 times 6 minus 4, which would be 1/2 of 6 is 3. 3 minus 4 is -1. F of 8, 1/2 times 8 minus 4 would be 4. Half of 8 is 4 minus 4, which would be 0. There's our x-intercept. We knew that one already. And then f of 10, 1/2 times 10 minus 4. So that would be 5 minus 4, which would be 1. Do you have to do it this way? You could use a calculator and put this in the calculator and use the table feature. That would be okay. I think it's important to kind of refresh your memory, because sometimes you put something in the calculator and just because you see the answer doesn't mean you know where it came from. Okay, you should have a ruler at home, a straight edge. Let's do a quick sketch or a quick x and y axis on our graph paper. And I'm noticing that my lowest y value is -3, my highest is 1, so that's why I'm putting the x-axis so close to the top. And then I'm going to put the y-axis kind of to the right, giving myself some space, or actually to the left, because I want to give myself some space to reach +10. So there's a lot of thought into going, I mean, you could just grab a sheet of graph paper and then cut it out of the graph paper. A lot of thought into figuring out where to place your graph on a piece of graph paper. So -2, -5, 0, -4, 2, -3, 4, -2, 6, -1, 8, 0, 10, 1. There's our graph. And some of you are going to say, Miss, I could have done that without doing the table. That's awesome. But for the homework, gotta do the table. Okay, so here's my x-intercept, 8, 0. Here's my y-intercept, 0, -4. And that process is extremely important. So if you need help with any of that, one-on-one help, come see me for tutoring. Let's get you where you need to be. Okay. I think we're done. Yay. Yeah, that's it.